In this video, we're going to look at a few different types of questions that represent multiplication that students will be able to practice using the materials in my Dropbox. The first type are just what I call straight multiplication questions, so 7 times 4 or 3 times 8. So the 7 times 4 is 28 and 3 times 8 is 24. If you haven't already done so, please take a few minutes and watch my video that focuses on these types of questions and the patterns behind them and the skills that students should be practicing. The next type of question are area questions. So students should recognize that multiplication represents the area of a rectangle. If we take the first rectangle here with dimensions of 4 and 7, you could divide the rectangle in one direction into 4 and in the other direction into 7. And then by counting all of the little squares, you'll find the area of the rectangle. Multiplication is a much more efficient way of finding the area of rectangles, especially given the large numbers that students will have to work with. So when students are asked to find the area of a rectangle, what they need to do is find the product of its dimensions. So the dimensions here are 4 and 7. So the answer would be 28 centimeter squared. In the second example, students will do the exact same thing, but the dimensions are different. In this case, the dimensions are 6 and 8 for an area of 48 centimeters squared. It's very important for students to be able to visualize multiplication and division on number lines. This is something that's newer to the students, although they're used to using number lines for addition and subtraction. So the few steps that we've practiced in class when working with number lines, step number 1 would be to count the number of spaces on the number line. So in my first example, there are 4 spaces. And then we want to find the value of each space. And we do that by finding the difference between the two numbers. So in this case, 3 minus 0 is 3. And then it becomes a multiplication question. So the value of each space is 3. There are 4 spaces total. So the number that goes on the line is 12. What we want to avoid are students having to put numbers on each of the lines or on each of the benchmark. This represents an addition, not a multiplication. And in this case, we're really practicing our multiplication skills. So in the second example, if I count the number of spaces again, I have 4 in the first half of the number line. So there will be 8 spaces total. And the value of each space, if I find the difference between 0 and 5, is 5. So to find the number here, I would multiply the value of each space, which is 5, by the number of spaces that I'm working with, which is 8. And the product of 8 and 5 is 40.
So now we're going to look at a couple of questions where students are going to have to partition a large number in order to help them with their multiplication. So in this case, 208 and 307. So by partitioning, we're just looking at breaking up the number into easier chunks in order to make the multiplication easier. Really important that students slow down and look at the number. It's not uncommon while we're starting to practice these types of questions where students will just look at the number of digits and break up the number in that many parts, even though it's often not necessary to do so. So if students need a visual to practice these, we're going to go back to something that we know, which is our area model. So we know that multiplication represents the area of a rectangle. So we're going to go use that in order to make this multiplication easier. And we're going to use how we've partitioned 200 here and kind of break up the rectangle in a similar way, just to give us a nice visual. So now we're looking to find the area of two smaller rectangles. And because I picked the numbers, I know that they're easy for me to work with. So the product of 8 and 9 is 72. And the product of 209 is 1,800. So then to find the product of 208 times 9, I really just have to add the product, or the area, of these two smaller rectangles together. So 1,800 plus 72 is equal to 1,872. And what you'll notice here is that creates kind of three steps. Step one would be to use the visual to help me kind of see the parts of the numbers and the partial products. Step two would be to kind of skip the visual piece, do the breaking up, the partitioning in my head, multiply my two easier numbers in my head, and then just kind of write out these answers so I don't forget them. And step three would be able to really kind of talk my way through this question and jump right to the final product. So I know these numbers are large and students are sometimes a little, I don't want to say scared, but maybe scared is the best word, kind of nervous to start removing some of these supports. And often just don't believe that they can do these types of questions in their head. But we're going to practice it a lot in class, and hopefully you'll practice it at home as well. So that if a student is looking at a question like this, the first part that's really important, our brain really kind of works very well from front to back of numbers, even though most of our procedures start with the smallest digits. So in our heads, we want to be able to talk ourselves through, well, what is the product of 308? I know that's 2,400. The product of 8 and 7 is 56. So 2,456. Again, students need to be able to self-assess and know what they need, right? Do I still need to draw my area model? Do I still need to write down the answers to my smaller multiplication questions? Because while we're learning or practicing, that's completely okay. But we're going to practice enough and get comfortable enough and build our confidence so that we can get to kind of this point. So now we'll just move on quickly to the last kind of question that we're going to look at.
The last example that we'll look at is when working with algebra. And in this case, right now, students are only working with simplifying expressions. So if you look at the first example here, if a is equal to 7, what is the value of 4a? So it's completely acceptable for students to feel like they want to write out the multiplication sign, so 4 times a. Some students at this point are still thinking about it as a repeated addition, a plus a plus a plus a, but we really want to focus on our multiplication skills here. Although writing it like this is appropriate as students are learning and getting used to algebra, I always find it important to remind them that the multiplication sign, because it looks like the variable x, is typically not used in algebra. But in this case here, if a is equal to 7, then 4a is equal to 28. The second example is very similar, but there's an addition as a second step. So if z is equal to 4, 8z, or 8 times z, will be equal to 32. And then 32 plus 37 is 69. This is a good way for students to reinforce their multiplication skills, their algebraic skills, but also review their addition skills from earlier in the year. It's really, really important for them to continue practicing those skills as we move into multiplication and division. As usual, there are practice material available on my website. Thanks for watching.